This problem here, this is an example of a work problem. So in this case, what we're going to do is we're going to fill a pool with an inlet pipe, and then we also have an outlet pipe. So I'm going to draw a picture of what's going on here. So maybe we have a pool here and an outlet pipe, and there's an inlet pipe here. And what do we know? Well, it takes 10 hours. So if the water's on all the way, it takes 10 hours to fill the pool, an empty pool. But if the pool is full, then the water's coming out the outlet pipe, and it takes 15 hours to drain the pool. And what we want to know is that if both pipes are open, how long would it take to fill this pool, right? How long would it take to fill the pool? Well, we don't know, so let's call that x. So I'm going to say let x equal the amount of time to fill the pool with both pipes open. Now here's how I'm going to set this up. This inlet pipe here, it can fill up the whole pool by itself in 10 hours. So let's see what happens here. I'm going to draw a picture. So water starts coming in, it fills up all the way to the top in 10 hours. So I'm going to break everything into 1 hour units. So if it takes 10 hours to go from the bottom to the top, what fraction of the pool gets filled in 1 hour? So in 1 hour, it fills 1/10 of the pool. So in 1 hour, this inlet pipe can complete 1/10 of the job. Now what about this outlet pipe? The outlet pipe can take a full swimming pool and drain the whole thing in 15 hours. So suppose I'll do it in yellow here. All right, suppose that the pool is full and we're going to drain it out, and you can drain it out in 15 hours. So in 1 hour, it can drain 1/15 of the pool. So in 1 hour, the outlet pipe can complete 1/15 of the job. So now, the entire job, what do we have going on here? Well, in 1 hour, the inlet pipe contributes 1/10, the outlet pipe contributes 1/15 of all the work. So let's say this. The inlet pipe can complete 1/10 of the job by itself in 1 hour. Leave a space here. The outlet pipe can complete 1/15 of the job in 1 hour. But because the outlet pipe is working against the inlet pipe, I'm going to put a minus sign here. Right? This is coming in, so it's positive. This is going out, so it's negative. Now, this is right here, this is the fraction of the entire job that can be done in 1 hour. But this fraction here is equal to, well, what do we know? What do? We let x be the amount of time to fill the pool with both pipes open. So it takes x hours to do the complete job. So what about in 1 hour? Well, if it takes x hours to do the whole job, now I'm going to come back over here. Okay, I'm going to come back over to this. It takes 10 hours to fill the pool, so in 1 hour it can do 1/10 of the job. It takes 15 hours to drain the whole pool, so in 1 hour it can complete 1/15 of the job. Now here it takes, everything together, it takes x hours to complete the whole job, so in 1 hour, it can complete 1/x of the job. So we are going to say that this is equal to 1 over x. So here's our equation. I'll write it up here again. It's 1/10 minus 1/15 equals 1 over x. Rational equation, we know how to solve it. Let's get the LCD. The LCD is about 30x. Make sense? 10 and 15 will go into 30 and the x. All right, so I'm going to multiply 30x here, here, and here. So it all looks like this then. We'll get 30x times 1 over 10 minus 30x times 1 over 15. That's equal to 30x times 1 over x. So we'll get some cancellations here. 10 into 30 is 3, so we get 3x times 1 is 3x minus 15 into 30 is 2. We get 2x times 1, which is 2x, equals, those x's cancel. We get 30. So what do we get here? x equals 30. Now this is a word problem, so follow it all the way back. What was x to begin with? X was the amount of time it takes to fill the pool with both pipes open. So our answer is not x equals 30, but rather 30 hours. So with both pipes open, it takes 30 hours to fill this pool.